Hello everyone. Today I am going to explain the topic deep learning. I am Mrs. Padmashri from SNS College of Engineering. In deep learning, we'll be seeing the continuation of my previous lecture series, which I have explained AlexNet architecture, and where we are going to use RELU, rectified linear unit. So, what is the advantage of using this RELU in the convolutional neural network? It mainly focuses on maximize the output value, right? Which retains the essential features as it is, and it filters any error present in the layout, which is the use of RELU. We'll see the continuation, and there are in my previous lecture I explained about two functions. One is the sigmoid and other one is the tan h function. Then we saw RELU function. So RELU, rectified linear unit, so which means over the sigmoid functions. For the same reason, we have overfitting problem. Okay. So AlexNet had 60 million parameters. The major issue in terms of overfitting, we are going to use two methods to reduce the overfitting. So you all know what is this overfitting, underfitting, everything. So which we have already discussed in my earlier lectures. So how to we in RELE also we faced some problem, the overfitting problem, but we need to reduce this overfitting with the help of data augmentation, and we have a dropout concept. So data augmentation is also referred. It is a principal component analysis on RGB pixel values to change RGB channel intensities, which reduce the top one error rate by more than 1%. Okay. Then we have a dropout function. What is this dropout function? The second technique we use for in the AlexNet to avoid the overfitting was a dropout. So, from the name we say drop out. We are going to drop something out. What is that? It has a setting to 0, the output of each hidden neuron, the probability 0.5 percentage. So, the neurons which is not participating in the neural network transaction or thing, we are going to drop that neurons out. Okay, which are dropped out in this way, that the neurons do not contribute the forward pass, which means which do not transmit the data from one convolutional layer to the other convolution layer, which do not participate in back propagation. Like we may get some data, some error data during the transmission, right? So the thing is we need to back propagate the error data to the again back to the input. Again we need to add a new weight, calculate that, then again we have to propagate it. All these things are there. So some neurons will not participate, which means not actively present in the neural network architecture. Such kind of neurons we are going to drop it out from the network. That is the concept of dropout. Okay, so in neural network, every time input is presented, the neural network samples a different architecture. Okay, this is a technique consisting of turning off the neurons. The dropout is a technique which is turning off neurons with a predetermined probability. So we have a probability of 0.5 percentage, right? Here we have like each hidden neurons with a probability of the output of each hidden neuron with a probability of 4.5%. So this has a turning of the neurons with a predetermined probability. This means that every iteration the neurons will be turned off. They do not contribute. That particular neurons will not. They do not contribute to forward, pass forward the data, and do not participate in back propagation will be dropped out. See, you could see here some of the neurons is in green color, and which is not in green is called that is not participating in forwarding process. pass forward in the sense transmitting the data from one neural one layer to the another layer. See the one green, see it receives the input and it sends the input to the next neuron. See here also it receives input, sends the input to the next neuron. This processing happens. Then again from this neurons to another neuron, from here to another neurons. All these three neurons receives the input and again it transmits it to the output. So the network you can see here there is a formation of network between the neurons and you could see some of the neurons is not at all participating in the network, see which is idle. That is the thing that we can drop those neurons out. So, what is the advantage? Which helps, which reduces the complexity of the network. Since if we have more number of neurons in the convolution neural network, which increases complexity, so we could drop out those neurons to reduce the complexity. So till now we have discussed about the convolutional neural network architecture example, AlexNet, and what all the layers present in the Alex network, everything we have discussed. And the image. Now I'm going to tell you that what are the applications of AlexNet. It is used in image classification, object detection, face recognition, and scene understanding, image generation. So, image classification, identify, categorizing the images. Object detection, identify the various image, faces, cars, etc. Face recognition, we can recognize the different faces of facial features of humans. And scene understanding can be used to analyze images, interpret the context and semantics, indoor, outdoor, day, night, weather, etc. Image generation, using AlexNet, we can also generate realistic images like a human real face, art, any artwork or sketches, etc. These are all the various applications of AlexNet. The pros and cons of AlexNet, which is mainly used the milestone of CNN as image classification and convolution plus pooling design, dropout, GPU, parallel computing. Many methods are used in this Alex network. Okay, the unique advantage is direct image input to classification model. We are giving a direct image input, pixel images. Layers can automatically extract the edges of image and fully connected layer learning these features. And theoretically, if we want to explain the complexity of visual patterns can be effectively extracted by adding more convolutional layers. That is, one of the cons is not deep enough compared to other model. BGG, GoogleNet, and REST. So these two, RESTnet and BGGNet, I'll be discussing in my next lecture series. Do watch that. The use of large convolution filters, 5 into 5 is not encouraged shortly, and use normal distribution to initiate the waves in the neural network, which cannot be effectively used for solving the gradient problem. And the performance is surpassed by more complex model like GoogleNet 6.7 and REST 3.6. So the rest of these example VGG net and REST I'll be explaining in my next lecture video. Thank you.